Unit 7, Topic 0, Simplifying Radicals. Some of the problems in this chapter will have answers that require simplifying radicals. Let's take a look at that process. First, we start out with the square root of 18. The secret to simplifying radicals is to look for factors of the number that are perfect squares. So perfect squares include 1 squared is 1, 2 squared, 4, 3 squared, 9, 4 squared, 16, 5 squared, 25, 6 squared equal to 36, 7 squared equal to 49, 8 squared equal to 64, 9 squared equal to 81, and 10 squared equal to 100. Anytime we see that one of our numbers is divisible by one of these perfect squares, we'll be able to rewrite it. For instance, I know that 18 is 9 times 2. So I'll rewrite 18 as the square root of 9 times the square root of 2. Because 9 is a perfect square, the square root of 9 is equal to 3. Therefore, the square root of 18 simplifies to 3 square root of 2. Let's repeat that process with the square root of 72. This one's a little bit different. So let's start by taking out the easy things. I see that 72 is even. That means that I can divide it by 2. 72 divided by 2 is 36. Aha! Over here, I see that 6 squared is 36. So this will be one of my perfect square numbers. So rewriting 72, I have the square root of 2 times the square root of 36. Because 36 is 6 squared, I'll rewrite this as the square root of 2 times 6. We're always going to put our whole number first, so let's rewrite this as 6 square root 2. Next, let's take our 4 square root 50. I know that 50 is 2 times 25, where 25 is another one of my perfect squares. So 4 square root 50 can be rewritten as 4 square root 2 times 4 square root 25. The square root of 25 is 5. Therefore, I have 4 times the square root of 2 times 5. Right? When I rewrite it with my number first, I get 4 times 5 square root 2, or 20 square root 2. Lastly, let's simplify 3 times the square root of 12. I know that 2 factors of 12 are 3 times 4. I can see that 4 is equal to 2 squared. So I can do 3 times the square root of 3 times the square root of 4. Or 3 times the square root of 3 times the square root of 4 is 2. 3 times 2 square root of 3, or 6 square root of 3. Now, let's simplify radicals where our square root is in the denominator. This is not considered simplest form. I can never have a radical in the denominator. So, to move it, I can multiply the top and the bottom by that radical. I'm not creating anything out of thin air. The square root of 2 divided by the square root of 2 is just 1. So I have 1 times the square root of 2, and the square root of 2 times the square root of 2 is 2. Anytime I take a square root times itself, it removes that square root. And I'm done. So now let's check out 3 over the 5 square root 75. Step 1, let's get this radical into simplest form. So I know that 75 is 3 times 25. Therefore, I have 3 over 5 square root 3 times the square root of 25. That square root of 25 is one of my perfect squares. So I'm going to put 3 over 5 times 5 square root 3. To move that square root into my numerator, I'll multiply the numerator and the denominator by the square root. So in the numerator, I have 3 square root of 3. And in my denominator, I have 5 times 5, which is 25, times the square root of 3 times the square root of 3. Right? So I can see that I have 3 times the square root of 3 divided by 25 times 3. Because I have 3 as a factor in both my numerator and denominator, they eliminate. And I'm just left with the square root of 3 over